Okay, so while I was tutoring tonight and dealing with small children, I was thinking about the line integrals that we were working on today. And some people had asked if I could come up with like some real world examples that would maybe kind of make sense, that agree with stuff we've done before, so we could kind of get an idea of what's going on geometrically here. And we had said that one way to think about this is it's like the area under a curve, only instead of having a curve like we do in 2 dimensions in the xy plane, where my curve looks like this and I get this area, now in 3 dimensions, I have some curve in space that maybe goes from here to here. And then the line integral is getting me the area underneath that curve, which we kind of call a curtain we had set in class. So I was sitting there, and we have that formula for a line integral. So we're going to do a line integral here, but my function f of x, y, z is going to equal 5, which is just a flat plane, height 5 in the xyz plane. My parametrization r of t is going to be cosine t, sine t, 0. I know I'm kind of squeezing this in on here because I don't have much room on the board. And of course, we know that parametrization will just give me the circle, and here the last component is 0 to make sure it actually gives me just a circle, not a helix or anything like that. So now if you think about it, this is going to give me the entire plane of height 5 right here. This parametrization in XYZ gives me the circle. So when I project it up, I'm going to get, it's hard to see here in 2 dimensions, I'm going to get a circle of height 5. Then logically, the line integral we said would essentially give me the area underneath that curve. But since it's a circle of height 5, the actual shape I get is a cylinder. What the line integral then should give me is the outside of the cylinder. The surface area of the cylinder, assuming you don't include the top and the bottom. Again, this is not flat, this is just the curve around the outside edge. So it's a curtain that I've pulled into a circle. And this should give me a surface area of a cylinder, that part of it. So then, that we can actually find, we know the formula for surface area of a cylinder is 2 pi r squared plus 2 pi rh. And in this case, if you recall, this part right here is pi r squared. It's a circle on bottom and the top. That's why there's 2 of them. We don't need to include that because we only want the circular part here. So that's my formula. And I can tell really quickly, the cylinder is going to have height 5. It's going to have radius. Well, we know the radius here is just going to be 1, which means I should get 2 pi times radius 1 times height 5. That part of the cylinder has a surface area of 10 pi. If this is actually giving me the area underneath the curve, then that integral should give me 10 pi. So now we can test it. So let's see. First I need to have f composed with r of t. Which is just f of r of t, which is cosine t, sine t, 0. But the good thing here is f is a constant function 5. So the composition is still just going to give me 5. Then I need r prime of t. R prime of t is just derivative of cosine is negative sine t. Derivative of sine is cosine t. And the derivative of 0 is 0. Now I need the magnitude of that. The magnitude of r prime of t is just the square root of negative sine squared is sine squared t, plus cosine squared is cosine squared t, and then 0 squared is 0. Sine squared plus cosine squared is 1, which means the magnitude is 1. Now I have everything I want. We know to get the circle, I didn't list it up here because I ran out of room. T ranges from 0 to 2 pi because we need it to be 1 to 1. So now set up my integral. It's the integral. T is ranging from 0 to 2 pi of f of r of t, which for us is 5, times the magnitude, which is 1, dt, which is just the integral from 0 to 2 pi of 5 dt. which is just 5t, evaluated from 2 pi to 0, which is 10 pi. Which is exactly the surface area we should be getting for this. So we had done a few examples in class. This popped into my head because it's one we already know, the surface area of a cylinder. And in theory, then maybe this will give you another geometric way of looking at this that will help it make more sense. And as I said in class, if there's other topics you want me to make videos of, examples, whatever, just let me know.